Good morning. So welcome to the Geodetic Astronomy Chapter 2. So in this presentation, I'm going to discuss you the geodetic astronomy. So let's discuss first the objective, and let's start with the introduction of geodetic astronomy. Okay? So celestial coordinate system, meron tayong apat. We have here the horizon system or tinatawag nating altazimuth coordinates system. We have the right ascension equator system or yung radix. You have the R angle equator system, the ecliptic system. So let's start kay horizon system. Si horizon system, ito yung tinatawag again na altazimuth because yung ating angular measurements na di-determine kay horizon system is the azimuth and si altitude. So, let's focus kay horizon system. So, the horizon system, meron siyang primary reference na horizon. Secondary reference na ay si vertical circle. So, yung parameter, when we say parameter, ito yung value na nakukuha natin or yung angle na nakukuha natin sa ating reference. We have the altitude. Ito yung altitude is the angle from the horizon to star. Ito yung angle na measure natin kay horizon to star. Ang partner niya is si azimuth. Yung azimuth, this is just a similar azimuth na alam natin on the Earth, but projection lang siya on the celestial sphere. So, the angular distance measured along the horizon from the observer's meridian to the vertical circle through the body. When you say a body, there could be a star, any star, or the sun. So, to illustrate the parameter and the references, for example, ito tayong observer's meridian circle. So, si Earth, yung GE. Ito yung ating horizon, di ba? North and south. So, have here the south point and the north points. So, meron tayong body, for example. So, yung great circle na nag-pass through kay nag-pass through kay zenith, nag-pass through kay nadir and the star, ito yung tinatawag natin na vertical circle. Diba? Vertical circle. And this one, diba? And sa Philippines, reference natin yung south. In the other countries, reference nila is north. So, example, yung azimuth natin, ito yung angular distance measured along the horizon, measured and from the south. So, pag sinabi nating azimuth with respect to the celestial coordinate system, ito yung nami-measure natin from here. Ito. Ito yung angle. That is now the azimuth. Ito yung azimuth ni star. Okay? Or azimuth ng body. So, this is the azimuth. So, pag in-increase na naman natin yung telescope, if we take up the telescope above, di ba, nare-read natin yung vertical angle. So, from the horizon, 0 degrees from the horizon, i-incline natin ang telescope until makikita natin yung sun. That is now yung vertical angle na nire-read ni theodolite or ni total station, that is now the altitude of the star in terms of angle. Okay? So, we can now determine this one naman, di ba? Pag meron tayong altitude, meron tayong tawag na zenith distance. Yung zenith distance, that is angle measured from the zenith to the star. Yung zenith angle na nababasa ni total station, so this is the zenith distance or the zenith angle. So, it is sometimes convenient to consider the complement of your altitude. When we say complement, that is the difference of 90 degrees. So, complement ni altitude, which is the zenith. So, yung altitude plus kay zenith, that is 90 degrees. So, zenith distance, again, if you are going to determine the zenith distance, this is just the difference of your 90 degrees minus the altitude. Okay. So, meron din tayong tinatawag na parallel. So, ito yung mga small circle na parallel kay horizon. Ito yung tinatawag natin na almocantar. Okay, so they are small circles parallel kay horizon. So, second, we have the right ascension equator system. Ito yung again tinatawag na radic. So, radic ang tawag sa kanya because in reference na, we have the right ascension and the declination. So, ano ba si right ascension? Ano ba yung tinatawag nating declination? Okay, let's start. So, meron tayo dito si equator. For example, ito ang ating equator na naka-inclined. Sa ibabaw ng, this is the zenith, yung sa itaas. Here, this is the zenith. And opposite kay zenith is si nadir. And we have here the south celestial pole and the north celestial pole. So, yung ating earth is medyo nakatagilid. So, meron tayong body, for example. So, yung great circle that pass through kay North Celestial Pole, South Celestial Pole, and kay body, again, that is called the hour circle. Yung tawag inawag circle. So, the angle measured from the equator, tas pataas siya, along the meridian, along the great circle, or along the hour circle, that is called the declination. Again, yung angle measure natin from the equator, along the hour circle, ito yung white, that is called the declination of the star. So, we can use also the complement of the declination of the star. Again, that's declination of the star. So, we can use the complement of the declination. Ito yon. So, that angle measured from the North Celestial Pole up to the star, ito yung tinatawag natin na polar distance. So, yung ating declination plus polar distance, that is equivalent to 90 degrees. Sige, complement lang siya. Okay. Zenith, nadir, North Pole, North Pole. So, it is sometimes convenient to consider the complement of the declination, which is the polar distance, which is yung din pakita ko kanina. So, your declination plus the polar distance is 90 degrees. So, the polar distance is equals to 90 minus declination. So, meron na tayong sa right ascension, di ba? Right ascension equatorial system, dalawa. We have the declination and the right ascension. So, let's now focus kay right ascension. So, paano ba natin ma-determine si right ascension as a reference? So, this is the coordinate system. Si right ascension, so the second coordinate is defined by the hour angle. Hour angle lang siya ha, taken from a fixed point on the celestial equator. Ano ba yung hour angle? Ano ba yung ating fixed point in the celestial equator? So, let's move to the next presentation. So let's now determine the second reference in which the right ascension is being determined. So meron tayo ditong equator. So itong yellow. So yung ating equator is intersected by this circle which is called the ecliptic. Yung ecliptic, ito yung path ng sun around the earth. So, kabaliktaran to in the actual, tayo yung umiikot sa sun. But in this setup, ilalagay natin niya yung path ng sun mismo, tayo yung nasa center. So, for a 1 year, ito yung ating path ng sun. So, at that instant, nag-i-intersect yung ating path ng sun sa equator. At that point, kung saan nag-i-intersect yung ating ecliptic and ang ating equator is called the vernal equinox. So, si vernal equinox, ito yung point where nag-meet na yung ating ecliptic and si equator. So, it's known as here. So, ito yung tawag na vernal equinox. So, the same goes to this illustration. Meron tayo ditong hour circle ni star. For example, ito yung ating vernal equinox in which nag-meet sa ecliptic in yung ating equator. Tapos, meron tayo dito first point of Aries. So, si first point of Aries, ito yung ating vernal equinox. This is the astrological symbol for the zodiac sign Aries. So, yung ating right ascension, this is a angle measure on the equator. Nami-measure natin siya sa equator, horizontal angle, from the projection of your vernal equinox to the position, to the meridian where the star lies. So that is our right ascension. Ito yung angle na white. So that is now the angle right ascension. Yung ating right ascension is the angle measured from the vernal equinox along kay equator. That is counterclockwise. So, si right ascension. So, yung right ascension natin is the angle taken counterclockwise along the celestial equator from the first point of Aries, which is called the vernal equinox, which happens in the Aries, and to the hour circle of the star. So, that is the right ascension. Okay? So, si right ascension, again, yung reference niya ay si equator and si hour circle ng star. So, yung parameter na nakukuha natin, number 1, si declination. Again, yung declination niya is na measure natin siya from the equator along sa hour circle ni star. Si right ascension naman, that is the perpendicular kay declination. Si right ascension is the angle taken counterclockwise along kay equator from the first point of Aries, in which yung tinatawag na vernal equinox, to the hour circle of the star. Okay, complete na. Meron tayong declination and right ascension. So, something to remember, for an observer on the Earth, so the sun moves counterclockwise, di ba? Relative to the star during the course of the year. So, thus, your right ascension is continuously increasing. Okay, nag-i-increase yung ating right ascension as the year goes round. So, the sun moves along the great circle that is inclined to the equator, di ba, nag-i-incline, hindi naman the same yung path na tinitake ni ecliptic and the equator. Nag-i-incline sila. So, the sun moves along a great circle that is inclined to the equator by an angle of 27 degrees 27 minutes. So, yung tinatawag nating path ng sun is again the ecliptic. So, ito yung traverse the trace of the sun's apparent annual journey around the celestial sphere. So, yung apparent journey ng ating sun. So, the ecliptic is the projection of the plane of the Earth's orbit on the celestial sphere. So, kung makikita natin yung path ng sun along the ecliptic, so the Earth revolves annually around the sun, and the sun appears to move from west to east on the celestial sphere. So, the path of the sun is called now the ecliptic. So, you have here what happened to the, at the moment where the sun revolves around the Earth. So we have here, along the ecliptic, so we have here the observer's meridian circle and the equator. So this is along the equator intersection. So ito yung ating first point of Aries. So itong first point of Aries, in where the intersection again ng equator and the ecliptic. So this happens actually on the March 21, on the date. So it happens usually 21 or 22. So at this moment, yung ating sun's declination changes from negative to positive. So, pag March 21, yung ating declination. So, pagdating niya naman ng June, 3 months after, di ba, pa-increase. So, from March, April, May, June, pagdating ng June, exactly June 21, yung rate ng change ng sun's declination is 0. So, hindi na siya, at pagkarating mismo ng June 21, yung declination niya, yung change, hindi na siya nag-move. So, zero ng kanyang changes o yung movement. So, this is the where the declination of the sun is at highest, 23 degrees and 27 minutes. So, 3 months after, di ba? September, June, July, August, September. So, yung ating sun naman is babalik dun sa kabilang position, opposite kay vernal equinox. So, what happens here? This one. So, from this point, so nakita nyo, this point here, this is June, happens June 21. After June 22, nagmo-move pag here, natin sun. So, at this point here, this is, so, from March to June, that is the movement. And from June to September, this is the movement. Where at September, yung ating, the sun's declination changes from positive to negative. Kasi pababa na yung ating path ng sun. So, at that instant naman, from September 22 to September, October, November to December 21, yung declination ng sun naman is at lowest, which is negative 23 degrees 27 minutes. So, yung rate of change niya kanina is from from positive to negative, from September to December. So, yung rate of change naman ng sun at this point on the December, so, pareho kay June, which is, yung rate of change niya is back to 0. And from December naman, pabalik kay December, January, February, March, that is, yung movement rate of change niya is from negative naman to positive. So, bababa siya, pabalik. So, itong yellow, buong yellow, that is now the path or journey ng sun, which is now we call the ecliptic, yung yellow na great circle. So, counterclockwise yung movement ni sun. Okay. So, what happens during this position? So, at March 21, nang nangyayari yung solstitial coulure. Sa solstitial coulure, nandito sa Aries, first point of Aries yung ating solstitial coulure, which makikita natin yung ating vernal equinox. So, when we say coulure, solstitial coulure, yung night and day is equal, yung coulure. That is the mean. So, solstitial coulure happens in the month of March 21. And 3 months after, that is June, that is summer. So, tinatawag siyang summer solstice. So, longer ang kanyang night, longer ang kanyang, sa summer, longer ang kanyang day compared sa night, that is summer solstice. So, after kay summer solstice, 3 months, diba, nag-intersect na naman yung ating ecliptic at the back. So, yung tinatawag na autumnal coulure, which happens around September 22. That is autumn. Autumn na sa lugar. So, we have autumnal equinox. So, the same, yung kanyang length ng day, the same din yung length ng night at that instant. Pagdating na naman niya ng September, October, November, December, 4 months after, pagdating niya ng winter solstice, so longer ang kanyang night, longer night, and shorter days. It happens in the winter solstice. And back, pabalik, so happen naman ang solstitial coulure. So, ito yung the apparent path of the sun on the earth, yung pink color, that is the ecliptic. So, yung ecliptic pole, opposite niya sa ibabaw ng projection lang ng ecliptic. So, the intersection of the celestial sphere and the line perpendicular to the ecliptic passing through the center of the earth. Si solstitial coulure again, the hours perpendicular to equinoctial coulure. So, the solstice, or it calls, si solstice, di ba, mayroon tayong summer and si winter solstice. So, ito yung intersection of the solstitial and the ecliptic. So these are the point wherein the sun reaches the greatest angular distance from the equator. So pag summer, yung declination niya, mas malaki yung distance between the equator, which around 25 degrees, 27 minutes. Pagdating naman sa winter solstice, negative 25 degrees and 27 minutes. Yung difference in angle niya sa ecliptic and sa ating equator. So, number 3, we have the hour angle system. Si hour angle system, meron tayong, for example, ito yung ating, so this is the star. Meron tayong hour circle, di ba? Yung circle na pass through kay North Pole and star, that is the hour circle of the star. Si local hour angle, ito yung una nating parameter, si local hour angle. Ito yung angle measured clockwise from the upper branch of the meridian of the observation to the meridian of the celestial body. When we say upper branch, the meridian of the observation, kung nasaan yung location ng observer, yung branch na o yung meridian ng observer, patungo until ma-meet niya yung hour angle ng ating star. So, you have here the equator. For example, meron tayong equator. Yung dalawang plane nag-intersect is yung equator and the dalawang plane. This is the primary reference niya sa equator. Secondary reference niya ay ang hour circle ng star. So, this is the, for example, this is the upper branch. Ito yung meridian ng observer. And ito yung position. So, this white angle here, that is the local hour angle. So, this is the angle measured clockwise. Nakikita niyo yung direction. Clockwise from the upper branch of the meridian of the observation to the meridian of the celestial body. So, meron din tayong tinatawag na sidereal hour angle. So, this angle measured clockwise from the meridian of the vernal equinox. Again, from the meridian of the vernal equinox, kung saan yung meridian ng vernal equinox to the meridian of the body. So, kung meron tayong vernal equinox at this point here, tapos mag-create tayo ng this angle, counterclockwise, clockwise angle measured from our meridian ng vernal equinox. So, that angle is called the sidereal hour angle. So, yung Greenwich hour angle natin, that is measured from the projection ng Greenwich on the surface of the Earth. So, this is the angle measured clockwise from the Greenwich meridian when which 0 ang ating longitude to the meridian of the celestial body. For example, meron tayong Greenwich meridian. This one here. So, 0 ang ating longitude at that area. So, this is the Greenwich hour angle. So, ito lang yung angle measured clockwise from the Greenwich meridian to the celestial body along the equator. Okay? So, looking from the North Pole, imagine nandun tayo sa North Pole. So, nandun tayo sa itaas ng North Pole. And this is the top view. Ito yung ating Earth. Diba? Top view tayo. This is our upper branch. Yung observer, ito yung observer. So yung ating upper branch. So, if this is our star, ating Greenwich meridian, this is the body. Yung lower part natin, this one here, ito yung ating vernal equinox. So, that is called measured from the upper branch to star. Ito yung tinatawag na local hour angle. Pag sinabi naman itong angle measured from the vernal equinox to the star, tinatawag nating sidereal hour angle. And the angle measured from the Greenwich meridian to the star, tinatawag nating Greenwich hour angle. Clear? So, yung longitude ng place, ito yung the same longitude na alam natin, which is measured from the Greenwich meridian to the location of the observer. That is now the longitude of your place. Okay? So, si right ascension, di ba? Si right ascension, ito yung maliit. We have here the angle measure from this one. So, from the vernal equinox to the position of the star. Okay? So, if the star is east of the observer's meridian, yung time natin is equals to 360 minus the local hour angle. So, if the star naman is west of the observer's meridian, yung time natin is equivalent lang ng local hour angle. Okay, yung fourth our fourth celestial coordinate system, we have the ecliptic system. So, yung ecliptic niya is parameter, we have the celestial longitude and the celestial latitude. So, basically, yung ating plane consists of the ecliptic system and the horizon and the observer's meridian circle. So, let's not go deep in the ecliptic system. So, let's focus on the first two. We have the R angle and the right ascension, equatorial system. So, this will be the end for the first part of the geodetic astronomy. So, next presentation, we are going to discuss the transformation of one celestial coordinate system to another. So, stay tuned.